Welcome back to Tech Pulse, the show where we break down the latest breakthroughs in science and technology, making them not just digestible, but actually exciting. I'm Vapor.
And I'm Puck, your resident, wait, what does that mean, guy? So you don't have to be. Quick reminder before we start, hit that subscribe button, drop a like, and share us with a friend who secretly geeks out over space news but pretends they're only into sports.
Today's headline is a big one. The James Webb Space Telescope finds a carbon-rich planet and maps dark matter.
Okay, you had me at carbon-rich planet. That sounds like either a sci-fi novel or, I don't know, the next Netflix special? What are we actually talking about here?
So, in two separate studies, NASA's Webb telescope pulled off two game-changing discoveries. First, it found an exoplanet. That's a planet outside our solar system with an atmosphere almost entirely made of carbon. Second, it delivered the sharpest ever map of something called the bullet cluster, giving us fresh clues about dark matter.
Okay, pause. Exoplanet, I get, but carbon atmosphere? What's so unusual about that?
Good question. Normally, planets have a mix, like Earth with nitrogen and oxygen, or Jupiter with hydrogen and helium. But this one, called PSR J2322-2650b, mouthful, basically has carbon cranked up to extreme levels.
Let me guess, it's one of those planets orbiting a weird star?
Exactly. It orbits a millisecond pulsar. That's a super dense, rapidly spinning remnant of a dead star. Picture something the size of a city, but more massive than our sun, spinning hundreds of times per second.
Whistle. That's terrifying.
It gets wilder. This planet's atmosphere has exotic molecules, tricarbon and dicarbon. On Earth, you'd only find those in comet tails or flames, not in planetary atmospheres.
So this place is basically a giant flaming carbon ball?
In a way, yes. Its carbon to oxygen ratio is over 100. For context, Earth's is just 0.01. And the carbon to nitrogen ratio, more than 10,000. On Earth, it's about 40.
Okay, hold up. Those numbers are off the charts. Like, if Earth is a teaspoon of sugar, this thing is the entire candy aisle.
Perfect analogy. And it's tidally locked, meaning one side always faces the pulsar. That side heats up to over 2,000 degrees Celsius. The other side, almost featureless, probably smothered in soot.
So, day side is a blazing inferno, night side is a carbon ashtray. Real estate value, 0.
Unless you're into barbecue themes. But scientifically, this is huge because it challenges our models of how these planets form.
Okay, let's switch gears. You mentioned dark matter and the bullet cluster. What's the scoop there?
Right. The bullet cluster is actually two galaxy clusters that collided about 3.8 billion light years away. Each cluster contains thousands of galaxies, tons of hot gas, and most importantly, a massive halo of dark matter.
Dark matter being that invisible stuff we know exists because of gravity but can't see?
Exactly. Webb helped map the bullet cluster's mass distribution with unprecedented detail. Turns out the whole cluster has several 100 trillion times the mass of the sun.
100 trillion suns? Yeah, okay, no big deal.
And here's the kicker. Previous estimates were higher. Webb refined them downward, showing dark matter passed straight through the collision, basically unaffected.
So dark matter is like a ghost at a mosh pit. Everyone's bumping around, but it just slides through.
That's weirdly accurate.
But why is that important? Like, who cares if it's trillions of suns or trillions minus a few?
Because it tells us how dark matter behaves. These new observations support the idea that dark matter only interacts through gravity, not other forces. That rules out a bunch of alternative theories.
So we're narrowing in on the mystery, like playing cosmic Guess Who?
Exactly. And the same study confirmed something called intracluster light, those faint stars floating between galaxies. actually trace dark matter pretty reliably.
Wait, so random orphan stars can help us map invisible matter? That's like using breadcrumbs to track a ghost.
A poetic way to put it, but yes.
So bottom line, Webb is changing the game again.
Yes, on one side, we've got a carbon planet that forces us to rethink how planets form around pulsars. On the other, we've got the bullet cluster map giving us the strongest constraints yet on dark matter.
And both discoveries came from the same telescope. That's like LeBron James playing basketball at night and winning chess tournaments in the morning.
That's Webb for you. Versatile, precise, and rewriting textbooks faster than we can keep up. So, to wrap up, Webb just showed us a bizarre carbon-soaked exoplanet and tightened the screws on dark matter theories.
And we'll keep bringing you these cosmic updates, minus the jargon overload. Though I do enjoy dropping a tricarbon now and then.
That's all for today's episode of Tech Pulse. If you enjoyed this, hit like, leave a comment, and of course, subscribe so you never miss a peek into the future.
I'm Puck.
And I'm Zaper.
Thanks for tuning in. See you next time on Tech Pulse.